So number 8, reciprocal crosses of Brahman, Angus and Brahman. You would expect the following with respects to birth weight, and then all are correct except. So this is the reciprocal crosses between Bos Indicus, Bos Taurus breeds. So Brahman being your Bos Indicus and Angus being your Bos Taurus. And this is that couple of those lectures where Dr. Riley talked about all the effects, good and bad, due to these due to this type of cross. So the reciprocal crosses, heavier Brahman sire calves by as much as 20 pounds as compared to the Angus sire calves. That one was correct. Brahman sire calves are heavier by about 20 pounds compared to Angus sire. So A and B contradict each other. So because you have 20-pound heavier calves, you're not going to have exceptional calving ease of the Brahman sire calves. So that, obviously A's incorrect and the correct answer choice, but we're going to keep going through. Small sets, birth difference weights between Angus sire compared to the Brahman sire. So there wasn't a very big difference in birth weight for these reciprocal crosses for the sexes. And then especially heavy Brahman sire bulls, so that's or bull calves. That's the same thing as B and A, or talking about the same sort of concept as B and A. The Brahman sire bull calves are extremely heavy, so you would not have this calving ease, but they are as much as 20 pounds heavier overall, not just bull calves, but including the heifer calves as well, compared to the Angus sire calves. So these two are both correct, as well as C. And then E, a higher variance of birth weight in Brahman sire calves as compared to Angus sire calves. So you do have that higher variance of birth weight from these reciprocal crosses. And that's all that Dr. Riley talked about in his video about reciprocal Bos Indicus, Bos Taurus crosses. So if you're a little unaware or got this question wrong, don't know why, a great place to start would be to go back and watch those lectures about Bos Indicus, Bos Taurus reciprocal crosses. So number 9, which of the following is true about the Callipyge trait? So Callipyge was in his last lab, and remember, Callipyge is double muscling in sheep, so that makes A wrong because it's not goats. All heterozygotes express Callipyge. Remember, the allele has to be inherited from the sire only. It can't be inherited by the dam, so that there are circumstances where heterozygotes would not be Callipyge. Expression of the double muscling occurs during fetal development, so that's not true. That is double muscling in cattle. You can see in the fetal development, but in sheep it doesn't occur until, I can't remember how old they are, but at least a couple, maybe a month old, maybe 2. So C's wrong. D, individuals cannot carry the Callipyge gene without expressing it. That's false, like we said. And B, you can be a heterozygote and have the gene, but not express Callipyge due to inheriting it from the dam instead of the sire. Which leaves E, the correct answer of Callipyge individuals only carry one Callipyge allele, and that has to be inherited from the sire. Remember, if they carry 2 Callipyge alleles, yes, they inherited the allele from the sire, but they also inherited from the dam. And Callipyge is only expressed when the Callipyge allele is inherited solely by the sire. So that's why E is correct. Number 10, which of the following is true when considering the breeding of F1 Brahman Hereford females to Charolais bulls? So, in the very first question, we had this Brahman Angus females mated to Charolais bulls, and we said that's a good example of production system complementarity. So this is a Brahman Hereford instead of a Brahman Angus females bred to Charolais bulls. So this is a great example of production system complementarity. So that one is true. Because we have this F1 female, we're going to have 100% maternal hybrid vigor, or the entire female will have, or the offspring will have, or this entire female, well, there's 100% direct hybrid vigor due to the parents being 2 different breeds. And because she had 100% direct hybrid vigor, she'll pass down 100% maternal hypervigor, being an F1. The cross results in total breed heterozygosity in the offspring. This is true as well because our Charolais bulls that we're putting back on these Brahman Hereford females, there's if we were to say a Brahman Charolais female crossed with a Charolais bull, we'd have 50% breed heterozygosity or direct heterozygosity because there is Charolais in the female. But now since it's Brahman Hereford bred to a Charolais, we'll have 100% or total breed heterozygosity in the offspring. And then the cross is an example of a terminal breeding system. I talked a little bit about this because you have the Charolais is an extremely terminal breed. Using it as your sire on any cows gives you a terminal breeding system or calves that are ready to go to market. So this one, the correct answer choice was all of the above. On number 11, what loci have intermediate heterozygotes that give other loci? Sorry, what loci have intermediate heterozygotes given that the other loci allow it? So the dilution in cattle. Remember, this is where we have, in hogs. This is where we have. Sorry, my mind went a little blank. We had the red. The red, the sandy, and the white. The roaning in cattle. Remember, this is where I'm going to use shorthorns for example. We have red, a red roan or just roaned, and then white. Dilution in cattle. Remember that that gene is going to be, let's say it's black, or let's just say it's red. A red cow, then half diluted gave us straw, and then fully diluted was white. And Tobiano horses. Remember, the only way you either are Tobiano or you're not. So either Tobiano or not. So which ones have an intermediate heterozygote? Well, that's these dilutions and roanings that have the sandy roan and straw intermediate as heterozygote. And these are just examples. That's the way it is in hogs, but in cattle, you could have used another example instead of, I just used a shorthorn breed. Dilution, I said a red cow that's diluted. But you can do black cows, and that would give you smoky instead of straw. So there are intermediates for other things, but these loci all have intermediates. So the correct answer choice is E. Dilution in hogs, dilution in cattle, and the roaning in cattle. So moving on to number 12, expected progeny differences. Exact measures so that there will never be unexpected results. Remember, this isn't true. That's why there's accuracies assessed with it. Expected progeny differences are just estimates, only for bulls, not for cows. That's definitely not true as well. Even though most people only use them for bulls, you can. There's definitely EPDs on a cow for certain traits. Accuracies of EPDs never change. Remember, that's false. Accuracies can be increased by the more offspring that they have, and so the accuracies do change. As an accuracy of an EPD increases, so does the possible change value. Remember, the possible change value will decrease because you're more accurate in your estimate. And so the answer choice is D, only estimates that have error associated with them. They're only estimates that have error associated with them because of the fact that they are just estimates. That's why it's expected progeny difference. We just expect it. We don't know for sure. Number 13, what's the objective of a progeny test? So remember, the progeny test is to figure out if you have a carrier or not. So calculate an individual's initial probability of being homozygous dominant. Remember, that's not true. A progeny test would be more the LOC, the level of confidence. So we wouldn't be calculating the individual's initial probability. To identify homozygous recessive individuals in the population. Remember, that's not it. We're trying to figure out if we have a carrier because homozygote recessive, we'd be able to tell. Test an individual's fertility. A progeny test has nothing to do with fertility. You're just trying to put animals on the ground to increase the probability of an animal not being heterozygote or knowing that an animal is heterozygote based off of the offspring's traits. And then E, calculate hybrid vigor in the offspring. Has nothing to do with hybrid vigor. Hybrid vigor has to do with the breed compositions of the crosses. So it's D, identify the heterozygotes in the population. Duroc should have been another easy question right here. I've mentioned before, it is a terminal breed of swine. It is from the U.S., but has down ears and red with dark skin pigmentation. That's correct as well. So answer choice here, that one should have been easy. All of them were correct.